Welcome, everybody. Today we will be going through the January 2025 Regents Exam, and we will be going through the multiple choice section. You should have definitely some scrap paper, the DESMOS calculator, graphing calculator open, and it should be in test mode, and also the reference sheet because we can use these tools to answer a lot of questions. Okay, let's begin with number one. When factored, the expression x to the third power minus 36x is equivalent to. Whenever we see this word equivalent, there's a strategy we can use with the graphing calculator. So we're going to type in the expression that is in the question, and we're basically looking for whichever answer choice is equivalent to this. And if whatever we type in is equivalent, equivalent pretty much means the same. So the graph should be exactly the same, overlapping. So here is the expression from the question. Now I'm going to test out choice one. And make sure when you type it in, type it exactly as you see with parentheses and all. So we can see the graph for choice one is not the same, so it's not choice one. Well, let's test out choice two. Also, not the same. I'm going to use like a brighter color here. Not the same. Okay, let's test out choice three. And there we can see the graphs are the same, which must mean that these two expressions are equivalent. So the answer is choice three. All right. Question two. Which equation represents the line that passes through the points -1, 8 and 4, -2? This is another question where the graphing calculator will be very helpful. So basically what we're going to do is check each, we're going to graph each line and check which one has those 2 points on the line. So let's type in choice one, y equals -2x plus 6. We can trace along the line and see all the points that are on it, but it might be a little bit easier if we just type in the points. So -1, 8 and 4, -2. And both of those points are on the line. So the answer is choice one. Passes through the points means that the line goes through those points, which in other words means the points are on the line. Okay, question three. A geometric sequence is shown below. What is the common ratio? So one thing to note is that there's a section of our reference sheet which has some formulas that work with sequences. So geometric sequence, the formula's here. We won't really need to use this formula for this question, but it's just something to know that we have that information on the reference sheet. A1 is your first term. This might also help if the question required you to know some vocabulary. And R is the common ratio. The common ratio is basically the multiplier. So we need to figure out what these numbers are multiplying by. What do we multiply to get from one number to the next? Okay, well, let's see. We basically have to figure out 1/2 times what is 2. 2 times what is 8. 8 times what is 32. And the answer would be 4. We can test out the choices. And the answer choice would be 4. And another way to figure this out is to take any term. Term is just a number in the sequence. So any term, let's say 32. And if I want to find out 8 times what gets me 32, I'm working backwards, I can divide. So I can do 32 divided by 8, and that would give me 4, which is the common ratio. So to find the common ratio, you can take any term and divide by the previous one. Okay. Number 4. What is the constant term? Let me just clear this out. What is the constant term of the polynomial 2x to the third minus x plus 5 plus 4x squared? So the word constant means like stays the same. right? So constant term means there's no variable. Variable means something that can change. So constant is the opposite of that. So constant term is the one without the variable. In this case, our variable is x. So the constant term here is 5 because there's no x with it. Constant term is 5. Okay. Question 5. A landscaping company charges a set fee for a spring cleanup plus an hourly labor rate. The total cost is modeled by the function c of x equals 55x plus 80. In this function, what does the 55 represent? Okay, this is a common type of question where we have a linear function and they want to know what like some part of it represents in the context. Whenever there is a set fee or something that doesn't change, like a one-time cost, a one-time fee, anything that doesn't have to do with a variable, it's just a one-time, like a one-time cost that'll always be that same cost. That will be the term that the number that doesn't have the variable, so it'll be the constant term. So 80 has to be our set fee because they're just going to charge that fee no matter how many hours this thing takes. They will always just charge $80. That must mean that the 55 is the hourly rate because X has to be the number of hours that this job takes. So 55 would be the hourly rate. Okay, and oftentimes in this kind of question, the variable represents time, the number of hours, because that could change. A different cleanup might take a different number of hours. So we would let that be our variable, x. And then 55 gets multiplied with x because let's say that the job took 3 hours. We would have to do 55 times 3 for those 3 hours and then add the set fee. So in this case, though, it's asking about the number 55, and that will be the hourly labor rate for cleanup. So choice 2. Okay. Which expression is equivalent to? Okay, another question where we can use our DESMOS strategy. So I'm going to type in what's in the question, and then I will test out each answer choice to see which one has the same graph, because that would mean that they would be equivalent. So I'm going to type it in exactly as I see it in the question, parentheses and all. 5x squared minus 2x plus 4 minus 3x squared plus 3x minus 1. Now my answer choices, I'm looking for the one that completely overlaps this graph because that would mean it's equivalent. So let me test out choice 1, 2x squared plus x plus 3. I can see that the graphs are not the same, so that's not my answer. Let's test out choice 2. 2x squared minus 5x plus 5. And there I can see the graphs are exactly the same, so that means these two expressions are equivalent. So my answer is 2. All right, number 7. A system of inequalities is graphed on the set of axes below. Which point is a solution to this system? So system means more than one. So we have two inequalities on the same graph. For each inequality, the shaded area is representing the solution. So here's one of them in green. And also note that the points on a solid line are solutions as well. And the other inequality is represented by this dashed line and this shaded area here. So everything in that blue shaded area is a solution to that blue inequality, except for the points on that dashed line, because points on a dashed line are not solutions. So we have two inequalities on the same graph, which is what it means by system. And the solution area for a system of inequalities is where both of them are shaded at the same time, because it has to satisfy both inequalities in the system. So we basically want to pick any point that's in this double shaded area where I can see both of the colors overlapping. So I'm going to clear it off so we could see it a little more clearly, but I'm looking for points that are in the double shaded area. So let's look at choice 1. The point 1, 1 would be right here. Now, that point is on a dashed line, so it cannot be a solution to the inequality that has the dashed line. So no, it's not choice 1. But that's a very common wrong answer. Just remember, if the point's on a dashed line, it's not a solution. So it's not choice 1. Choice 2, 2, negative 2. Let's see where that point is. 2, negative 2, right here. Again, it's on the dashed line, so they're trying to trick us. It's not choice 2. Let's look at choice 3. Choice 3, the point is 1, 8. So 1, 1, 2, 3, 4, 5, 6, 7, 8. I already see it's not in the double shaded area. It's not choice 3. So choice 4 is correct, but let's just see where it is. 4, 2. 1, 2, 3, 4, 1, 2. So the point 4, 2 is in the double shaded area. So that would be a solution. All right, number 8. In an arithmetic sequence, this phrase here should be giving me a clue here to go to my reference sheet because it might help me out. Any kind of sequence question. I might be able to use one of these to help. So in an arithmetic sequence, the first term is 25 and the third term is 15. What is the 10th term in the sequence? Okay, so let's look at our arithmetic sequence formula. We may want to use it for this question. So what do we know about the sequence? Well, we know the first term is 25. We don't know the second term, but we do know the third term. So I know the first term is 25. I don't know the second one. The third one is 15. Now, it would help here if we knew what the word arithmetic means. There are two kinds of sequences, arithmetic and geometric. Arithmetic sequences, they either add or subtract a number. And geometric sequences, they have a multiplier, like we saw in a previous question. But if you forget that, if you forget those words, look at the reference sheet. There are clues. So the geometric sequence formula says A1 r n minus 1. That means A1 times r to the power of n minus 1. So this one, geometric, is the one that has the multiplier, which is called the common ratio. Now, arithmetic sequence, we can see a plus sign. So that's the one that changes by adding or subtracting a number. That number is called the common difference. So we can figure out the common difference here. We have to figure out what number gets added or subtracted each time. Like, what is the pattern? Well, I can do a little bit of trial and error here, but I see that it's getting smaller from 25 to 15, so I know it has to subtract a number. And it subtracts over this space, 25 to 15. That's a subtraction of 10. But we have two, we have it happening twice, one from the first term to the second term, and then from the second term to the third term. So basically we have a subtraction of 10 in total, but we have to make that happen twice. Or we have to subtract two things to subtract 10 total. So basically we have to divide negative 10 by 2. We can get 5. But you could also do that with a little bit of trial and error. So my common difference here is negative 5. And let's test it out. 25 minus 5, I get 20. And 20 minus 5, I get 15. So my common difference is going to be negative 5. I'm going to write D equals negative 5. Now, at this point, you could list out the terms until you get to the 10th term. Just keep subtracting 5. But I also want to show you how to use the formula in case the question said, what is the 50th term or the 100th term, and you don't want to list them all out. So here's my formula. I'm going to just copy it down. AN equals A1 plus d times n minus 1. So an, you can read it as like the nth term. Now they're asking for the 10th term, so that means n is 10. N is basically like the term number you're looking for. So the 10th term equals A1 in the formula. A1 means the first term. I know the first term. The first term is 25 plus d times n minus 1. I know d is -5. So yes, it does say plus in the formula, but if we're adding -5, we can just write -5. And then n minus 1. N is 10, since we're looking for the 10th term. Let's figure out what that is. 25 minus 5 times 9. In other words, if we're starting at the first term and going to the 10th, we have to subtract 5 9 times. But we can do that with the formula here. So 25 minus 5 times 9 is 45. And by the way, just, check your arithmetic. Everyone makes mistakes, so I like to just be sure. But my answer is -20. I'm just double checking. 25 minus 5 times 9. All right, our answer is -20. Okay. Number 9. When the formula P equals 2L plus 2W is solved for W, the result is. Solved for W means we have to make it say W equals. So looking at all my answer choices, all of them have W equals. So I need to basically solve for W in this formula or get W by itself. So I start with P equals 2L plus 2W. If I want W by itself, that means I don't want this 2L here. So I'm going to subtract it from both sides. 2L minus 2L is 0, so I can cancel those out. I don't need to write 2W plus 0, so I'm just going to write on this side 2W. On the left side, I have P minus 2L. Now I want W by itself, but I don't have that yet. I have 2W, which means 2 times W. So to cancel out that 2, I need to divide both sides by 2, because 2W is 2 times W. So the inverse of that will be dividing. 2 divided by 2 is 1. And instead of writing 1W, I can just write W, which is 1 times W, or just W. And on the left side, I have P minus 2L over 2. My answer is choice 2. All right, number 10. Market Street Pizza kept a record of pizza sales for the month of February. The results are shown in the table below. Of all the pizzas sold in February, what percent were plain deep dish pizzas? Okay, so whenever I have a percent question, I know I'm going to be dividing two numbers because a percent is a part out of a whole or a part out of a total. So percent is a part out of a total. To help figure out what the total is, I'm going to look for the word of, because this part divided by total is the same thing as saying take a part out of a total. So I'm going to look for the word of, and then the next thing in the sentence, that will be my total. So of all the pizzas sold in February, this is my total. So it looks like we'll need to find the total number of all these pizzas. So we're going to add up all these numbers. 300 plus 80 plus 120 plus 100 plus 200 plus 25 plus 105 plus 70. So the total, or the bottom part of the fraction, the denominator, that's 1,000. total pizza sold in February was 1,000. What percent were plain deep dish pizzas? So plain and deep dish, right here, 200. So 200 out of or divided by 1,000. That's 0.2. To convert a decimal to a percent, I'm going to multiply by 100. Or move the decimal over to the right twice. But either way, I get 20%. Also, just a cool little Desmos trick. You can do this too to check. And that gives us that 200 of those pizzas. 20% of the 1,000 were plain deep dish. All right. When solving -2 times 3x minus 5 equals 9 over 2x minus 2 for x, the solution is. Another question where Desmos is going to be super helpful. Anytime there is an equation, usually we can use Desmos to solve it. Okay, so we're going to type in the equation. And it's going to show us the solution. Let me show you how. So I type it in exactly as I see it. And it's a vertical line. Vertical lines have the equation like x equals some number. Look how the x value stays the same on all these points on the line. So Desmos is basically plotting the solution points for us, but it's just, in this case, it's just an x value. So this is the x value, 1.14286. We just need to figure out which one of these is equal to that. Let's try 8 over 7. 1.14286, 1.14287. It's just rounded to 1.14286, so it's going to be choice 1. You can also see 10 over 11 is not close at all. So if you weren't sure, just check the other choices, but you'll see 8 over 7 is that number just rounded. So my answer is choice 1. Anytime there's an equation, Desmos can solve it. Just type it in. Look for the x value of any point on the line, but you can just click on the x-intercept. It's that number, that x value. All right, number 12. The expression x to the 2a plus b is equivalent to. All right, I see the word equivalent again, so I'm going to use the Desmos strategy. X to the power of 2a plus, let me play around with that. I should be able to type it in the exponent. X to the power of 2a plus b is equivalent to. Now, I want to add sliders for a and b, so basically that's me plugging in any number for a and b. Just don't choose 1, because sometimes some different things happen with the number 1, especially with exponents. So just choose any numbers that are not 1 or 0. Just pick like some other number, so 3 and 2. So it's going to plug in 3 and 2 wherever a and b are, so I can just use the same idea though, where I look for the choice that has the same graph as this one. Okay, let's test out choice 1. X to the 2a plus x to the b. That is not the same graph, so it's not choice 1. Let's test out choice 2. X to the a plus x to the a plus b. If you were having trouble getting the plus in the exponent there, just put that whole thing in parentheses, and it should stay in the exponent. But that is not the same graph, so it's not choice 2. Let's look at choice 3. X to the a times, I'm going to use that, times x to the a plus b. A plus b. Oh, these have the same graph. So my answer is choice 3. Okay, number 13. The inputs and outputs of a function are shown in the table below. This function can be best described as So linear function has a constant rate of change and it will be a straight line. So if that were to be linear, we'd be adding or subtracting the same number each time. Quadratic functions, they have a constant second rate of change. And exponential functions have a multiplier. Let's just see what the pattern is, and then we can apply it back to the answer choices. Okay, well, let's check. Am I adding the same thing each time? So 0.25 plus what is 0.5? Let's work backwards. Okay. But 0.5 plus 0.5 gives me 1, and then 1 plus 1 gives me 2. So it's not adding the same number each time. It's not linear. Quadratic would be if this rate of change, the second rate of change, was constant. This 0.25 plus 0.25 gets me the 0.5, and 0.5 plus 0.5 gets me the 1. So these are not the same number, so it's not quadratic. Let's check exponential. Exponential would mean if there's a multiplier. So let me work backwards and check. The same way we found the common ratio in the sequence by dividing, I can do that here too. So let's take any number in here, 1, divide it by the previous number. Okay, let's check if the multiplier is 2 for all of these. If it is, then this would be an exponential function. Okay, 0.0625 times 2 does give me 1.25. 1.25, oops, I made a typo here. 0.0625. Okay, either way, I get the next number. If I multiply that by 2, I get 0.25. So it seems to be working. 0.25 times 2, I get 0.5. 0.5 times 2, I get 1. And 1 times 2, I get 2. So basically the multiplier is 2. So it's an exponential function. Number 14. Stephanie is solving the equation x squared minus 12 equals 7x minus 8. Her first step is shown below. So if we figure out the first step, we can probably figure out which property is based on the name of it. So I do see when she started, on the right side of the equation, there was a minus 8, but now it is gone. So it looks like what she did was add 8 on both sides. Let's see. Negative 8 plus 8 would be 0. That would cancel out. Negative 12 plus 8 would give me that negative 4. So she added 8 on both sides. That would be the addition property of equality, which basically means if you add the same number to both sides of an equation, you get another equivalent one. So that's what she did. She added 8 on both sides, addition property of equality. Number 15. What is the sum of 8 square root 3 and square root 3? We need to know what this word sum means. It means when you add these two numbers. The sum is the result of addition. So let's just add them. 8 square root 3 plus square root 3. And then let's see which answer choice that's equal to. 8 square root 6. Nope. Not that one. 7 square root 3. Nope. Not the same. 9 square root 6. Nope, not the same. It's 9 square root 3. So 8 square root 3 plus 1 square root 3 gives me 9 square root 3. So the answer is choice 4. Okay. Number 16. The dot plot below represents test scores for 20 students on a math test. The mode for this math test is 80 and the median is 85. Which dot plot correctly represents this data? Mode means the number that occurs the most often. the most common number. And on a dot plot, each dot just represents one of the numbers that the dot is like on top of. So this means there was 160. This means there were 270s. So basically we need to look for which data set has 80 as the most often number, which would mean the most amount of dots on top of it, which would mean like the tallest. So in the first one, 80 is the tallest, so it could be the first one. In the second one, 80 is not the tallest. See this? It's not the tallest, not the one with the most dots. So it's not choice 2. 80 is not the mode. And in choice 3 up here, 80 is the tallest. Could be that one. What about choice 4? 85 is the tallest, not 80, so it's not this one. Okay, now we also have to check if the median's 85. Median is the middle number. When we find the median, we organize the numbers from least to greatest, but since the dot plot is set up on a number line, they're already kind of organized. So let's cross off the edges until I find the middle number, and I need it to be 85. Let's start with the first one. I'm crossing off from each end, one by one, and I'm making sure to do it evenly. Oops. So I do end up with 2 numbers in the middle, but this is exactly between 80 and 90, so these 2 dots represent 85s. So if I have 2 numbers that are in the middle, but they're both 85, the median is 85. So it is going to be choice 1. Median is 85 and the mode is 80. So it's choice 1. Okay, number 17. A function is graphed on the set of axes below. The domain of this function is, so let's say you forgot what the word domain means. There's kind of a clue in the answer choices. All of them have to do with x, not y. So the domain is the set of all the x values that are in the function. So on my x-axis, I can see that the function starts over here, which is at x equals -2. So I know the graph starts at -2 and then it continues to the right. As I travel to the right, my x values are getting larger. So that represents everything where x is starting at -2 going to the right means x is greater than -2. Like if I had a number line and this is -2, everything to the right of it is greater than -2. Now, the reason why I don't have the or equal to is because I have an open circle. You can think of an open circle as like a hole or a point that's not included on the graph. So an open circle means I'm going to use greater than, not greater than or equal to. So my answer is choice 1. Okay. Number 18. Which ordered pair is a solution to the equation y minus 1 equals 2 times x plus 1/4? Another question where Desmos is going to be our best friend. Okay, y minus 1 equals 2 times x plus 1/4. Okay, I've graphed the equation of this line. If an ordered pair or a point is a solution, it means it's on the line because a line is just a set of all the points that are solutions to the equation of the line. So I need to find out which one of these points is on this line. Again, like I showed you, you can click and drag, but I like also to just plot it and see. So the first point is not on the line. Let's check the second choice. Oops. 1.25, 4. That point is right on the line, so it's a solution to this equation. So 1.25, 4 is my answer. Okay, number 19. Elena's fastest time for the 50-meter dash is 7 seconds. She wants to know how fast this is in inches per minute. Inches per minute. Which expression can Elena use for a correct conversion? For these kinds of questions, we're going to see how we can cancel out units and be left with the units we want. And in this case, they're asking us to get our answer in inches per minute. We can cancel out units the same way we could cancel out numbers or variables. So if it's on the numerator and the denominator, we can cancel out that units. So let's look at choice 1. Let's see what units cancel out. Meter, meter. Does anything else cancel out? No. So we're not left with inches per minute. It's not choice 1. Let's look at choice 2. Second and second, but nothing else cancels out. Yes, I have meter, meter, but they're both on the bottom, so I can't cancel it out. Let's look at choice 3. What units cancel out? Second, second, but nothing else. So it must be choice 4, but let's just see. Second, second, meter, meters, and I'm left with inches on top and minutes on the bottom, which means inches per minute. So it's choice 4, inches per minute. Number 20. The table below shows the highest temperatures recorded in August for several years in one town. The interquartile range of these data is. Interquartile range is one of the things that's on our reference sheet. Here it is. So IQR is Q3 minus Q1. We do have to find Q3 and Q1. There is a way that DESMOS can do it for us. So if you go to functions and we go to statistics and we go to stats. So again, functions, statistics, stats. And I'm going to enter the list. What I'm concerned with is the temperature. That's what has been recorded. So I'm going to enter the temperatures. 86, 78, 84, separate each number with a comma, by the way. 95, 81, 77, 88, 93. Okay, now I did this on purpose because I do want you to see that if you type something wrong and you get an error, read what the error tells you. It says stats requires a list. For example, try typing. It's basically telling me how to type it properly. And look at that example. It gives me square brackets around the numbers. So we want to put the numbers, our list of numbers, in square brackets as well. And then it'll give us everything we want. Q1 and Q3. Okay, so our Q1 is 79.5, our Q3 is 90.5. Q3 minus Q1 is IQR, interquartile range. So Q3 is 90.5 and Q1 is 79.5. And when we subtract those, we get 11. So our answer is 11. All right, number 21. The function f of x equals x squared is multiplied by k, where k is less than -1. Which graph could represent g of x, which is k times f of x? So they're basically asking us which graph represents f of x times some number k. So that's what I'm going to do. I'm going to get f of x and multiply it by some number k. We don't know what k is, but we know k is less than -1. Okay. So without the k, if we just started with x squared, this is what our graph would look like. If we multiply by k some number less than -1, so look how I'm using the slider. Anytime the k is less than -1, and the less I make that number, it kind of pinches the graph and it makes it narrower. And also because k was negative, it flipped it upside down. So I have to look for the choice that looks like it's narrower, like squeezed in, narrower, and flipped upside down. So it is not choice 1. It's not flipped upside down, right? I'm comparing it to my original that I started with. So it's not choice 1, it's not choice 3. Choice 2 and 4 are both flipped upside down. But choice 4 is the one that looks like it was narrower or squeezed inward. So it's going to be choice 4. Number 22. Which graph is the solution to the inequality 6.4 minus 4x is greater than or equal to negative 2.8? So I can use DESMOS to help me solve this. The same way it can solve an equation, it can also help us solve an inequality. Okay, so I typed in the inequality, and I can use the keyboard, by the way, for these symbols too. Okay, so here it is. Look at how the x value remains at 2.3 on this like boundary line here. And the shading, which represents all the solutions, is to the left. And all the numbers to the left here, the x values are less than 2.3. As I move left, x gets smaller. So I need to show that x is less than or equal to 2.3, which is choice 4. These two have an open circle. Right away, I know that's wrong. And choice 2 shows x greater than or equal, which would be shaded the other way. So the answer is choice 4. X is less than or equal to 2.3. Okay. Number 23. I love number 23. I don't know why. I think it's a great question. I also like fish and I like frogs. The number of fish in a pond is 8 more than the number of frogs. I'm going to read this one more than once and underline some key quantities. The total number of fish and frogs in the pond is at least 20. If x represents the number of frogs, which inequality can be used to represent this situation? This is one that I would do 3 reads for. So the first read, I'm getting the idea. And the idea is that I have fish and I have frogs, and they're in a pond together. Let me read it again, look for some quantities, and I'm going to annotate. The number of fish in a pond is 8 more than the number of frogs. More than, or makes me think of adding, by the way, more than. The total number, total also makes me think of adding 2 things together, perhaps the fish and the frogs. The total number of fish and frogs in the pond is at least 20. At least makes me think of inequalities. 20 is the least it could be, meaning it's 20 or more, so it's at least 20. If x represents the number of frogs, so now I have x as the number of frogs, which inequality can be used to represent the situation. For this kind of problem, anytime they give me a variable, I like to go back to the question, find what's represented by the variable, and put the x above it to just help me read the sentence. So x is the number of frogs. Now here is frogs. Now let me read that again. The number of fish in a pond is 8 more than x. 8 more than x. So fish is 8 more than x, which means 8 plus x, or x plus 8. So that's like that first thing I underlined. The number of fish in a pond is 8 more than the number of frogs. So I know the fish is represented by 8 plus x, and I know the frogs is represented by x. The total number of fish and frogs is at least 20. Total means the fish plus the frogs. So 8 plus x, which is the fish, plus x, which is the frogs. So fish, frogs. That's the total. And I know that that total is at least 20, which means 20 is the least it could be. So that means it's 20 or more. So that quantity that I wrote, 8 plus x, has to be greater than or equal to 20. Greater than or equal to 20. Now, that doesn't look like my answer choices I have, but if I just combine the x and x here to get 2x, that'd be 8 plus 2x is greater than or equal to 20. Then I can see that it will be choice 2. 8 plus 2x is the same as saying 2x plus 8. So it's choice 2. Fun one. Okay, number 24. Which graph below represents a function that is always decreasing over the entire interval? -3 is less than x, which is less than 3. So this word interval is telling us like what section of the graph we are looking at. We are looking at the section of the graph between x is -3 and 3. So here x is -3 and here x is 3. So let me mark that area for all the graphs. -3, 3, -3, 3, -3, 3. I need to look for the graph that's decreasing in that section. So let's look at choice 1. It's increasing, not choice 1. Choice 2, it's increasing, then decreasing. Not always decreasing, not choice 2. Choice 3 is steadily increasing, so it's not choice 3. Choice 4, it is decreasing over that entire interval, so it's going to be choice 4. Alrighty, stay tuned for next time. We'll be looking at the short answer.